concept of set in the collections. Now today we are going to look at about working with the set interface. Correct? Let's go ahead. What I will do is now we'll start with the set now. Let's open a collections document. Okay, I'll open the collections document and we'll go ahead. Okay. In the last session, we completed up to this concept, guys. What is the difference between comparable interface and comparator interface? I told you, actually, I gave answer already. At the same time, we discussed about example of when to use comparable and when to use comparator. Okay. But I told you that please write the differences between comparable and comparator. I think you found the difference between comparable and comparator. Okay. Okay. So today we want to start with the next interface, guys. What's the next interface we are discussing? That is called set interface. We are looking about another interface which is called set interface. Okay. We'll start with the set now. I told already, first we need to identify some difference between list and set. We say set is an unordered collection. If you take a list, it is ordered collection, right? But set is unordered collection. Both are collections only, but set is unordered collection, which means you don't have any index. To retrieve the element, we don't have an index. And second thing is set does not allow the duplicate elements. I mean, if you are trying to add a duplicate element, it won't give any exception, but it won't add that element. First, we will check whether the element is exist or not, and based on that, okay, if the element already exists in the set, then that element will not be added again. Okay. First, we'll understand about what are the methods available in set. Then we're also going to look at about internally set uses a map object. Okay, so now we are going to look at about how internally the set is going to store the elements. All those things I'm going to talk about. Then I will write all the points. Okay, observe here. First, let us start with ID. We'll choose our workspace. Meanwhile, we go to Google and we'll ask java.util.set. Okay, so we are discussing about this interface, guys. Interface name is what? Set. Okay, now. So a collection that contains no duplicate elements. Okay. More formally, sets contain no pair of elements E1 and E2 such that E1 dot equals of E2. And at most one null element. Of course, we can add the null element, but only once. Okay. We call in collection all the objects, whatever we store in a collection are called elements, right? So set is a collection which does not store duplicate elements. Okay, right? And we can store one null element in the set. And if you talk about the methods, if you see add is a method we can add, which returns what Boolean value. If the element is added to the set, returns true. If the element is not added, returns false. Suppose if you are trying to add a duplicate element, do you know what happens if you are adding the duplicate element? If you are trying to add a duplicate element, then what happens, you know? Returns Boolean value as what? False. Because it's a duplicate element. Duplicate element will not be added. Of course, I'll tell you about how does it identify whether it's a duplicate element or not a duplicate element. Almost all the methods, whatever that are available here, these methods already, you know, these are the methods coming from collection interface. As I said already, collection interface also contains methods. Okay. Collection interface also contains methods. Almost all the methods, okay, all the methods are from collection. In collection interface also we have add method, add all method, clear, contains, equals method, hash code method, isempty method. You see, I'll show you the document. When you go up, if you go up, then you can see that there are some methods which are available in what? Collection interface. Okay. Let's see what are the methods of collection interface, guys. Let me show you. If you see the methods of collection interface, you can see add method is there, add all, clear, remove, contains, iterator, size, is empty, to array. So the same methods are even available in what? Set also. The same methods are even available in set also. Same equals method, hash code method, is empty method, iterator, remove, size, to array. These are all the methods of what? Set. Correct? Now, but the thing is what? Set does not allow duplicate elements. Okay. Which means what? If you are trying to a duplicate element, we don't get any exception, but the element will not be added. Okay. Element will not be added. Did you get the point, right? Okay. Set is unordered collection, which means what? Elements are not stored in the same order like how we are inserting or how we are adding. So how internal elements are stored, we are going to look at about that. We are just going to look at about that. How internally the elements are added, that we are going to look at about that. Okay, let's see. Internally, set will store the elements in a map object. Map is going to store the data in key value pair formats. The elements in a map are key and value pairs. Internally, set will use map for storing the elements. For example, hash set class we are going to discuss today. It will store elements in hash map object. Linked hash set class will store elements in linked hash map object. Tree set will store elements in tree map object. So hash map, linked hash map, tree map, these are the map classes. These are all the classes implementing map interface. Map is one more type of collection that is available in Java to store the data in the form of key and value pairs. So when you have a requirement to store the data as a key and value pairs, then you can store elements like a key and value pairs in map. That is also one more type of collection that we have in Java. Okay. So far I'm good with this, you guys. I'll start writing some points on this. Then I will show you how the elements are getting stored. Okay. Then how does it identify whether it's a duplicate element or not? All these kind of things I'm going to explain. Okay. Map does not contain any new method. Methods of collection interface are available to set also. Suppose if you take a list has index based, get of index, add of index, set of index, list iterator. But do you have all these operations on set now? We don't have these operations on set. Those operations are available for list object, but not available for set object. Okay, for set object, we have just common operations only, like add, remove, iterator, size, clear, to array. Only this type of common operations. These are common operations for list, set, and queue also. Only those common operations are available to the set. Okay, na? Am I clear with you guys? Did you understand the point? Okay. First, let me start writing the points here. Okay. I have explained many things. I want to write some points here. Let's back and start with the today's date. It's like 13th August. Okay. So here I want to start writing some points, guys. We are discussing about the set interface. Actually, we are discussing about set interface means we are discussing about hash set class. Okay. Hash set class, linked hash set class, and a tree set class. These are all the classes belongs to set type. So we are going to understand about them. Okay. I want to tell you about, first of all, set interface. Okay, we are looking about set interface, guys. Okay, set interface. Okay, good. What do you know about set? We know that set is a collection which does not contain duplicate elements. Okay, it's a collection. Okay, contains no duplicate elements, right? That's called set. So it is a collection which contains no duplicate elements. That's called set. Clear? We say that set is an unordered collection. Unordered collection. Okay, it means
no order.
The elements of the elements of set collection are elements of set. Elements of the set doesn't contain index. It doesn't contain index because it is unordered collection. We cannot access third element, fourth element by using index because it's a set. It doesn't contain any index. Am I clear, right? It is unordered collection and it does not allow duplicate elements. If it is a list, it is ordered collection. We have index. First element is having index of 0. Second element is having index of 1, like that. But in set, we don't have like that. Okay. So it means the elements of set does not contain index. That's called unordered collection. Okay. Right. So when we are adding an element to the set, okay, if the element is added, then returns true. Otherwise, returns false. Okay. Returns false means what? It's a duplicate element. Because of duplicate element, it is not added. Correct? We can store at most one null value. We can store at most one null value to the set or in the set. Okay. Guys, I told set internally uses map object to store the elements. Set internally uses map object to store the elements. Map object is another type of collection in Java. And it is used to store elements in key value pairs. And it is used to store elements in key value pairs. Okay, so map object is another type of collection in Java, and it is used to store elements in key value pairs.
With the help of hash function.
That I'm going to explain next. Okay, I will talk about internal things, but currently this is what I'm saying here. Okay, it uses map internally. I'm going to open the source code to understand that. Okay, clear. Guys, observe here. Now, set is an interface, right? Sorry, just 1 second. Guys, see, what I'm trying to say is now just for example, you take hash set. Hash set is a class which uses hash map object internally. Linked hash set class uses linked hash map object internally. Tree set class uses a tree map object internally. Like how we have hash set, linked hash set, and tree set, we have the map classes like, okay, hash map, linked hash map, and tree map. So first I want to write saying that, okay, the set classes are, I mean, set is an interface, it's implementation classes. The implementations of set uses the implementations of map. For example, I'll write hash set internally uses hash map. Hash set internally uses hash map. Internally uses hash map. Next, linked hash set internally uses linked hash map. Okay, tree set internal uses tree map. Okay, these are the different implementations of set and different implementations of map. Okay, linked hash set internal uses linked hash map. Tree set internal uses tree map. Now we'll understand about how we can work with the hash set. We'll discuss about hash set class. Okay, see, I'll show you how internally they are going to be stored. Let's say, for example, I want to open the source code of hash set class. Okay, I'm opening the class called hash set. This is from our Java API. Okay, cool. But you can understand internally hash set uses what object? Hash map object. Okay, hash map object. We know that map will store data in what format? Key and value pair. Means what? Internally hash set uses hash map object. You can see in the constructor of hash set, hash map object is created, which means internally hash set uses hash map object internally for storing the elements. But it will store elements in key and value, key value pairs. But to the hash set, we are only passing the value. We are adding some element. The element whichever is added to the hash set will be stored as a key. What about the value now? The value which is stored is a dummy object, which is called present, which is a dummy object, a dummy value to associate with an object in the backing up map. Which means what? See, for example, I will tell you in a single way. See, first let me say I am creating one. Let's say I'm creating one hash set object. How I'm creating a hash set object? Hash set of, for example, integer. Let's take for integers. HS is equal to new hash set. Am I clear with this? This is the way of creating what object? This is the way of creating the set object, right? Hash set object. Hash set is a implementation class of set interface, no? Correct?
Yes.
So basically I'm creating the set object. What I'm saying internally, what is created internally, this hash set uses what object? Hash map object.
Yes.
Now this is going to be the hash map object internally. This is internally one hash map object is created. So it stores data in the form of key value pair. So that's why I'm representing key and value like a table. Just I'm representing like a table. So internally, this is one hash map object. The first part, this is the key, this is the value. What happens, for example, I'm adding hs dot add of element 10. hs dot add of 10. Okay. So what happens now? 10 is the element I want to add to the set. But this 10 will be stored as a key. This 10 will be stored as a key in the hash map object. I repeat once again, this 10 will be stored as a key. But what about the value? For example, this 10 is stored here. I'll tell you how particular bucket is calculated. These are called buckets. Each row, whatever you are finding, in general, we call them as buckets. And these buckets having indexes from 0 to 15. Totally, by default, 16 buckets are created initially. 16 buckets are created, hash map object. Whenever hash map object is created, okay, when a hash map object is created, by default, 16 buckets are created. The size 16. We call each key value pair, each row that you are finding as one bucket. Each bucket have an index. Index is from 0 to 15. This is index 0. Like that, up to 15. Basically, 16 buckets are created initially whenever hash map object is created. Whenever I create a hash set object, internally this object is created. So here you're learning two things, a hash set and hash map together. But of course, I'll again specially talk about hash map. At that time, I'll talk about what are the new methods in hash map object and all. But currently, I'm talking with respect to hash set, what is happening internally. So for example, the bucket index calculated for 10 is out. I'll tell you what's the formula applied to calculate the bucket index. There is a formula for that. For example, this 10's index is here. Example. This 10 will be stored as key. What about the value then? Present will be stored as value. Who is this present? It's a dummy object. You can see here. A dummy object, static final variable, present, which is a dummy object. Okay, next, for example, if I'm adding, observe here, if I'm adding one more element called hs dot, okay, hs dot add of, let's say for example, element is 26. For example, this is the bucket index of 26. I'll tell you how the bucket index is calculated. That is based on hash code. I'll tell you. Okay, 26 is element here. Whatever the element I'm adding will be stored as a key. But whatever the value for all these elements is present. Present will be stored as value. Internally, this is how happening. Okay, for example, when I'm adding, once again, hs dot 10. Because 10 is duplicate element. Because 10 is a duplicate element. So we don't get any exception. But this add method now returns false value, which means this element is not added. It will be ignored simply. This is ignored. The element is not added. That's what I'm calling as ignored. For example, what guys? I'm saying like this, hs dot, okay? I'm writing what hs dot add of, okay, hs dot add of 12. Okay, or for example, the bucket index for 12 comes here. For example, I'll tell you how to calculate the bucket index. How the bucket index is calculated internal, I'll tell you. Value will be present. Like this. What about, I'm adding actually 4 elements, but actually 3 elements only stored in the map. Because this is a duplicate element. So duplicate element is not included. Am I clear with this? I'll tell you how the bucket index is calculated. These are called buckets. Internally, what object is created is hash map object. And the internal hash map object has a size 16 buckets. Each bucket is going to store key event value pair. Bucket indexes are from 0 to 15 by default. Okay, then I will tell you what happens if I add more than 16 elements. I'll tell you that how the hash map object will be resized. I'll tell you that. But what the value stored in this is present. And how a bucket index is calculated, I'll tell you the formula for that. Each element, for example, 10 you are adding. For example, 12 you are adding, 26 you are adding, or for example, maybe 8 value, element 8 you are adding. Okay, but they are not exactly stored in the same order. I cannot say that the first element add is 10, so its index is 0. The next element add is 26, its index is 1. In list, we can say like that, but in set, we cannot say, because it will store the elements based on index, based on what we can say hash code. Based on the element hash code, bucket index is calculated, and the element will be stored into that bucket as a key with a value present. So did you understand my statement, guys? Now, whatever I just explained, guys, did you understand this statement? Am I clear with this statement?
Yes, sir.
Okay. So how does the elements are stored in a hash set? The elements are stored in an internal hash map object. Whenever hash set is created internally, hash map object is created. And if you, while creating hash set object, if you don't specify the size, the internal hash map object is created with size 16. That's a default size, which means 16 buckets are created. Their indexes are from 0 to 15. And whenever you add an element, the element will be added to the internal hash map object, okay, into a bucket by calculating the bucket index. The element will be stored as a key, and present is stored as a value. For all these elements, who is a value? Present. Present is a one dummy object. It is an object of object class in Java. You know, object is a super class for all classes in Java. It's a dummy object, one empty object or dummy object that will be stored as a value. So how does this bucket is calculated? Bucket index is calculated based on a formula, based on hash code with a formula. I'll show you that. Okay, these are all internal things, guys. Please try to understand me. Of course, I'll give this type of diagram into the document for you for your reference purpose, but it's better to know first of all how it is working. Am I clear with this? Did you understood about all these things? Yes. Now.
Yes, sir.
Now I just want to show you the formula. Just we have something called as there is a formula where the resize happens. I mean to say that how the bucket index is calculated. Bucket index calculation formula is there. Otherwise, I'll show you somewhere. Hash map bucket index calculation formula. Okay. How does bucket index is calculated? Index is equal to hash code of the key. This is called bitwise end operator n minus 1, where n is the number of buckets or the size of the array, whatever it is. Where n is the number of buckets. Number of buckets means by default 16 buckets are there. Suppose if we create an empty hash map object, 16 minus 1, 15, that is what? By default, that's called n minus 1. N is the number of buckets. The formula is hash code of the key element. Key in the sense, whatever element we are adding, that is going to be stored like a key. And bitwise end operator, n minus 1. With this, what is calculated? The bucket index is calculated. Okay. So let's start with statements. We are talking about what? Hash set class, right? So I want to write some points on hash set. What's the statement I want to write is Okay, when a hash set object is created, okay, created internally, what object is created? Hash map object is created to store the elements. Am I clear? And when we add an element to the hash set object, what happens when we add an element to the hash set object? The given element will be stored as a key. The given element will be stored as a key, and what is the value? Present will be stored as a value in the hash map object. Who is present? I'm writing in cap letters. Present is a present is an object of object class. Am I clear with you? Present is an object of object class. Am I good with this point? Present is an object of object class, which is a dummy object. Okay, is an object of object class. And now, suppose while creating hash set, if you don't give any initial capacity, by default, how much size is created? With the size 16, initial
16.
capacity 16. Because internal hash map object is created the size 16 buckets. That's what I'm saying now. So while creating hash set object, if you don't specify the size, or capacity better, if you don't specify the capacity, then the object is created with a default capacity as a 16. It means, okay, it means the internal hash map object is created with 16 buckets. Okay, and of course the bucket index are from 0 to 15. 16 buckets. Each bucket is a key value pair, and the index of the buckets are from 0 to 15. I'm writing all the points very clearly. This notes is actually very, very important. I don't know whether you are storing this in safely into your drive or not, but whatever so far I have explained in core Java, this is going to be useful for you forever, which is very important. Now each bucket is a key value pair, and the index of the buckets are from 0 to 15. That's what we know. So what happens when you're trying to add an element? First of all, hash code of the element is calculated. Okay, and with bitwise AND operator, n minus 1, the bucket index is calculated with that formula. So when adding an element, the bucket index is calculated for that element. Bucket index is calculated for that element, and it is stored. It is stored in that bucket with that element as a key, and present as a value. This is one more statement I'm writing. Okay, now? And that element is stored as a key and present as a value. Next, what we need to understand is how the bucket index is calculated. So the bucket, the bucket index is calculated with a formula. With a formula. What's the formula? Index is equal to, index means not like our array index or something like that. Okay, it's a bucket index. So we cannot retrieve element by using this index. That's what again I'm trying to say, because it is unordered collection. This is bucket index. So index is equal to hash code of the element. Hash code of the whatever element you are adding will be stored as a key. So hash code of the key, bitwise AND operator, n minus 1. N is the number of buckets, where n is the number of buckets. Where n is number of buckets. Where n is the number of buckets. Maybe it is 16 or whatever it is. Okay, right? Now, if it is a string, or if it is an integer, or if it is a object of our class like employee, whatever it is, the bucket index is calculated like that only, based on the formula hash code of key ampersand n minus 1, where n is a number of buckets. Okay, cool. See, let me write the code first. I'm creating one hash set object now. So just I want to create one program called as hash set demo. Okay, I just want to create one. Okay, I'll start. I'll create one project called as hash set demo. Let's create hash set demo program. Guys, look at here. I want to start creating one new hash set here. First, I want to create one new Java file, something like a main class or whatever, just for sample. Let's create a new Java class. Okay, package name, enter something. com.ashokit.cf collection framework. Let's say just any package name of your choice. Next, class name. Class name I want to enter is something like okay, I'll enter the class name as test class. And I have main method, public static void main, right? Test class with main method. Then I want to click on finish. So here I want to start. I want to create one hash set object. How can I create hash set of integer? HS is equal to new hash set. I'm creating one hash set object now. Now I'm adding elements. HS dot add. So HS dot add of, I can just specify elements. The elements could be 12. It's an integer, right? Otherwise, we'll take string type better. Integers we can predict. Let's say string, hash set of string. Then I want to add strings now. For example, strings like Clark. Now HS dot add of, okay, something like Miller. Let's say HS dot add of Blake. And HS dot add of, once again I'm adding Clark. So it is a duplicate element. It is not added. Duplicate, not added. Because Clark is a duplicate element, so it is not added. We don't get any error, but it is something like, the element is not included. Now we can say HS dot add of Smith. Okay, some elements. And we can write HS dot add of null also. But only null, one null we can add. If you once again add null, it is going to become like a duplicate, again not added. So at most, how many nulls we can add to the set is 1.
1.
One null we can add. Okay, right? When you're retrieving elements, if you perform any operation on the null, for example, I want to find the length of null. For example, I want to find length of Clark, it is 5 characters. Length of Miller, it is, for example, 6 characters. But if you try to find the length of null, you will get null point exception. So thing is what I'm saying now, HS.add of null means we can store at most how many null values now? 1 null value we can add. Okay, I don't have an error there. Only 1 null value I can add. Okay, I'm adding all the strings, right? 1 null value I can add. Now, question is, can we get based on index now? For example, I want to get the Blake at index 3 or index 2, 0, 1, 2. Can I get like that? I can't.
No.
No, because it is not index based. Okay, it is not index based. And is these elements are stored in the same order exactly? No. Based on the
No.
bucket index, they are stored. Bucket index is calculated based on hash code of Clark, hash code of Miller, hash code of this word called Blake, this string called Blake or Smith, based on that, right? So that's why it cannot. So for example, I want to display all the elements now. How to display all the elements now? I can add for each loop. For string str colon hs, the collection object. This is called for each loop. I can say system.out.println of str. Let us run this program. Okay, let's run this program. Let's see what's going to happen now. Correct. Let's see how it is going to work. Let's run this code.
Sir, error. Line number 20 is error.
No, it is showing line number 20 is an error. But when I keep the cursor, it is saying that delete this token. Where is comma? Am I used anywhere comma? That's what I'm checking out. I have a semicolon here, line termination. All are semicolons only. This is a comment, of course. All double quotes, everything is correct. hs.add of null is also correct. Then I'm starting with the for loop. But it's saying on token parenthesis delete this token. Where is this delete this token? I'll refresh it. I'll refresh it. It is showing me like an error, but I'm not finding any error in this. I'm using angle brackets.
Update it then.
Right? I don't have anything. Same code I copied into this class now, but I'm not getting an error in this. So sometimes IDs also will play with us. Okay, right. Let's run this code now. Actually, same code. I just copied it from that class to this class. That's it. But I don't have an error actually. Okay. So I want to run this code now. I got the output here. Null, Clark, Miller, Blake, and Smith. Okay. We got the what we can say, the elements like this.
Ascending.
If you add more elements, it's not any ascending order descent, because this is B in lowercase, but this S in uppercase. In Blake, I written B in lowercase, this S in uppercase. It is all based on the hash code. Based on hash code, the bucket index is calculated, and according to that, it is going to be stored. Based on hash code, it is going to be stored. It is not like any ascending order or descending order. Okay, right. If I add multiple strings, you can identify that some strings may come on top, some strings may come on bottom because of the elements are stored according to their hash code. That's why we may not exactly predict the order. We may not get the exactly same order if I try to add some different elements. Okay, right. Sorry. But one thing we can understand that but Clark added twice, but in the output I got Clark for one time because duplicate element is not added. That's only one you can understand here. And we can also add a null value, but that too at most one time. I mean to say if I add hs dot add of null again, it's going to become duplicate. And again, if I print it, only one null will be printed. Okay, right? I'm printing the null. I'm not doing any operation on null, just only I'm printing the null. If I'm doing any operation, definitely I'll get null pointer exception. For example, if I'm writing str.length, if it is a null value, if str contains null value, then I'm going to get what null pointer exception because of length. I cannot call any operation on a null value. Okay, right. Internally, how they are stored, that we got it. Now, currently the size of the hash set is there are one null only stored, one Clark is only stored. So 1, 2, 3, 4, 5. Size of the hash set is 5. We can write hs.size returns 5. So system.out.println hs.size. But it returns me size 5. So it returns me size 5. 5 means there are 5 elements in the set now. Size is 5. That's what output is 5. Okay, right. Now this is also a duplicate element not added. This is a sample code for you. Just only this part I'll copy into the document. Next. Once you got it, let's go ahead to understand more things. Okay. Then I told internally by default the capacity will be 16. But when the size gets, for example, is it possible to add only 16 elements? No, it is not. It is not like that. It is not like that. What happens now? When 75% of the hash map object is filled with key value pairs, that 75% is called as load factor. Load factor is 0.75. 0.75 meaning 75%. It's a float value, 0.75. Load factor should be 0 to 0.0 to 1.0. If a 75% is filled, 75% of 16 is equal to 12 elements. What happens if the map object is filled with 12 elements, 12 key value pairs, then automatically that map gets resized to, okay, it's going to become 32, double. That's called the meaning of load factor. Okay, if it is doubled 32, then the bucket indexes becomes 0 to 31. 0 to 31. So the hash map size gets doubled when 75% of the map object is filled. Internal map object is filled. Okay, so that is called load factor. So basically, the point which I want right over here is you are understanding about a point called as load factor. Okay, so what is the default load factor? The default load factor of internal hash map object is for any map object, hash map, tree map, linked hash map, everything same. But currently I'm using hash map, so I'm writing with that. The default load factor of internal hash map object is 0.75. It means when 75% of the hash map object is filled, then its a size or its a capacity will be doubled. Okay. What's the formula? Okay, the formula is to check whether it is reached to 75% or not. That capacity into load factor. Okay, the formula is capacity into load factor to double the size. Capacity into load factor to double the size. See, for example, initial capacity is 16, na? 16 into 0.75 equal to how much? Equal to 12. 12. It means if 12 buckets are filled, then the internal hash map object or the backing hash map object, anything, backing or internal, any word, then the backing hash map object, size will be, or capacity will be, not size, capacity will be what? Backing hash map object capacity will be increased to 32 buckets. Double, na? 16 plus 16, 32, right? Like this. So did you understood about what is happening internally? These are all internal things that you should know. So almost you are learning hash set, but you are learning hash map actually, because internally hash set uses hash map only. That's the thing. That's why you're learning all these things. So while creating hash map object, let's see. For example, if I open hash set, look at what is happening in a hash set. So at the time of creating hash set, you can create, see, you can create empty hash set, construct a new empty set. So the backing hash map instance has default initial capacity 16 and load factor 0.75. Did you observe this statement? Please understand this once and tell me, did you understand this statement now? If I first only open this statement, you may not understand, but I have given all the explanation. I think now you people can able to understand it. Did you understand this now? This statement?
Yes, sir.
Yes.
Yes, sir. Understood.
Actually, we are creating hash set object, but backing what object is created? Hash map instance. And what's the default initial capacity? 16. And load factor?
16.
And load factor?
0.7.
0.75. Am I clear with this? Am I clear with this? Right? Yes. Please understand this. Am I clear?
Yes, sir.
Yeah. Please. Just 1 second. I got a call. Yeah, guys. If you look at this, okay, this now you can understand it. Internally, hash map object is there. It is capacity, load factor. Load factor value should be, it's a float value. It's not double float value. It should be from 1.0 to, oh, sorry, 0.0 to 1.0. That is the range. Next, coming to what guys here, hash set object. Here we can also create with initial capacity by ourselves, with the specified initial capacity and a default load factor 0.75. If I want to create load factor also by myself, I can also pass the load factor float. So hash set object can be created like this, or by passing another collection. We can create a new, this is to construct a new set containing the elements in the given collection. Suppose I want to create a set for a list. I can pass list object here as a parameter. Then I can create a set for list elements. That's how we can do it. I mean, we can copy the elements from a list into set by passing that list object as a parameter. Any collection object or a queue or a list. Third is hash set of initial capacity with a default load factor 0.75. Next, you can create a hash set object with initial capacity and load factor. Both you can specify. Default 16, default load factor 0.75. If you want to change, you can change it. That's what I'm trying to say. If you want, you can change it. For example, I want initial capacity with 10, load factor 1.0, which means after 10 elements are completed, I want to make it double to 20 buckets. Right? So what I'm saying is now, better I'll write all these points for you. This is all what you have to learn at the time of learning about the set concept. So that almost 50%, almost not 50, almost like 90% of hash map is also covered here. Almost 90% of hash map is also covered because of internal backing is hash map object only. We are actually discussing about set, but we are discussing map actually because Intel it uses map object. Okay. So what I'm saying is, while creating hash set object, we can specify the initial capacity and the load factor. For example, I'm writing what happens here, hash set of some string, for example, string or integer or employee, whatever. HS is equal to new hash set. What is created here? Okay, what it will do? It constructs a empty hash set object with initial capacity 16 and a load factor 0.75. Am I clear? So I'm writing a point here. Constructs a new hash set object with the initial capacity 16 and load factor, default load factor 0.75. Next, let me write hash set of string HS is equal to new hash set of only initial capacity. For example, hash set of, let's say 10. So what I'm writing here, constructs a new hash set object with the initial capacity 10 and load factor 0.75. Because we are not changing the load factor, so default load factor 0.75. Say for example, we create a hash set of integer or string, anything of string. Let's say HS is equal to new hash set of hash set of string. HS is equal to new hash set of what I can say 10 comma, let's say for example, 0.80. Okay, load factor value should be in between 0.0 to 1.0, correct? That's the default load factor. Default load factor 0.75. 75 means 75% filled. 80 means 80% filled. Right? 80% filled. So constructs. What constructs? A new has a set object with the initial capacity 10 and load factor 0.80. Actually 0.80 is wrong. Actually I should have 0.80 f. Why f? F is compulsory because of float. Okay, load factor 0.80. Am I okay? So am I good with all these things? All these the way now, like how we are able to construct the hash set object?
Yes, sir.
Okay, cool. See, you got okay how elements are added, what is happening internally, and we can also use iterator in place of for loop, and we can remove all these things are okay. That is what hash set you need to know, nothing more. But one thing, suppose if they are strings, if they are integers, they have a hash code method already. But what about if I'm adding employees or if I'm adding customers? Right? If I don't override hash code method, and if I add same employee for one more time, then hash set will not identify that it is a duplicate element. It will add simply. So let's write the code like this. Now this I want to remove it. Let's say I want to create one class on top of this that is called customer. Class customer. And for example, I'm taking private. I'll take string or integer, anything. Int ID of the customer. Private string name of the customer. And city. Customer ID, name, city. These are details of customer. Only 3 things are enough for me. ID, name, and city. What I want to do now, I just want to, create a constructor. Source constructor using fields. And I also want to create setter getter methods. Source, getters and setters. Select all, finish. And if you want, you can override toString method. Source. Yesterday we got the source toString method. You can override toString method. Generate. Okay. Now you have a class called customer. There are ID, name, and city attributes. Then this is the constructor. These are all the setter getter methods, and this is the toString method. Now we are going to main. In main, what we want to do in the main? We want to create hash set object. Hash set of customer. HS is equal to new hash set. HS dot add of new customer of ID is 101, name is A, city is HYD. Again, HS dot add of new customer of 102 is the customer ID, name is B, city is Delhi. Again, HS dot add of new customer of 101 A HYD. Question is, will it identify that? Is it a duplicate element now? Is this customer is a duplicate object now? This is also customer object, this is also customer object, but with the same data.
Yes.
Is this is a duplicate object? Will it identify that this customer object is duplicate now?
Yes, sir.
Yes.
Yeah. The answer it will not identify this as a duplicate element. It won't identify. Let's see. For example, if I display all these customers for using for each loop, or I can use iterator also, but I don't want to use iterator. I want to go with for each loop for customer colon HS collection, right? Sorry. Please try to get the point now. What I want to write is SOP customer. Will it identify this customer is a duplicate customer now? Answer is no. See, again, third customer also printed with the same ID 101 EA HYD, again 2 times printed. Means it is not identifying this customer as a duplicate. Why? That's why we have to override hash code method in our class. Because how can it identify whether it is a duplicate element or not? To identify that it's a duplicate element or not, it's going to find out hash code. But are you overriding hash code here? No, in the customer. If we don't override a hash code in this class customer, then you know that a hash code of the object class will be called. That will return the memory address converted into integer format. Obviously, the memory address of this object, even though content is same, even the data is same customer data, but this is a new customer object, its memory address different. This is another customer object, its memory address different. That's why hash codes are different. So did you understand this point clearly? Right? Did you understood how why it is not identifying it as a duplicate customer? Did you understood this point? Everyone? Can you give me some reply?
Yes.
Yes.
Yes, sir.
Did you understand the point now? Because I'm not overriding which method in my customer class?
Hash code.
Hash code. If I don't override hash code method, we know that object class hash code method is called. That's called a hash code method in object class is called. Correct? That will return the memory address as a hash code. Of course, that is converted to integer value. That's why it is not identifying it as a duplicate element. Both elements are added to the set. So to overcome this problem, which method I need to override in my class called customer now? Hash code method. Okay. Right. So first, I want to copy this for you before I make some changes tomorrow. But first, I want to copy this code for you and I want to give some statement. Simply not identified as a duplicate. Okay, why not identified as a duplicate? Because hash code method is not overridden.
Different.
Yeah. Next point. When adding custom objects, custom object means our class objects. While adding user-defined class objects to the hash set. If we don't override, which method? If we don't override, which method? Hash code method. Where? If we don't override hash code method in the class. We don't override the hash code method in that class. Or if you don't override a hash code method in the class, then the hash set cannot identify what elements? Cannot identify the duplicate objects or duplicate elements. Cannot identify the duplicate elements, and it will store the multiple objects of that class with the same data. It will store the multiple objects of that class with the same data. Example, the code is copied for you. Example, I'm copying the code for you. Please go through it. Okay. Am I clear with this?
Yes, sir.
Am I clear with this now? Why it is not identifying as a duplicate?
It is not overridden.
It is, we are not overriding. Which method we are not overriding? Hash code method we are not overriding. That's why it is not identifying as a duplicate. To identify as a duplicate, we should override which method then?
Hash code method.
Hash code method. Exactly. Okay. Now tell me how many customers are added here? 3. Oh, now what happens now? This code prints or simply output. Better I'll copy the output also. Instead of writing the comment, output I'll copy. And here I want to stop the session by copying this. I'll share these notes with you. Please go through it for today, which is very important things we discussed today. Output will be like this.
Sir.
Okay, so that tomorrow we'll discuss by overriding hash code method. Next, what is linked hash set? If you know hash set, then automatically remaining understanding is very simple. Because like linked hash set, we have linked hash map. There also initial capacity, 16 load factor, 0.75 bucket index is calculated, everything same, but there is some difference. So we have to discuss about only the difference between hash set to linked hash set, but otherwise it is going to be same. Remaining everything is same. Okay. So tomorrow we will look at about the continuation part. Okay. That's for today. We'll continue tomorrow, folks. Thank you.
Thank you, sir.
Yeah.